All right, class, today we're going to go over the answers to your proofs from last night's assignment. Feel free to follow along with me. For this first one, I know that ABC is equal to ADC. I'll label that. This piece is equal to that piece. And I also know that 2 and 4 are equal. My goal is to prove, I'm trying to prove 2 and 4 are equal. I know that 1 and 3 are equal. This is very similar to one we did last night in our homework. So we're going to start off with our givens. Angle ABC is congruent to angle ADC, and angle 1 is congruent to angle 3. And those are both given. We don't really know anything else in this picture, so the next thing I'm going to do is my angle addition postulate. So I'm going to say angle 1 plus angle 2 equals the measure of angle ABC, and the measure of angle 3 plus the measure of angle 4 equals the measure of angle ADC. Then my next step, I have everything taken out of my picture. My next step is really just to focus on doing some substituting and manipulating of the equations that I have. So I see that I have the measure of angle ABC and the measure of angle ADC. I'm still shooting for getting 2 and 4 to be equal. Well, conveniently, I can take this piece here and plug it in there. And I can take this piece here and plug it in there. So I have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And that's just substitution. And then your subtraction property says that you can subtract parts that are equal. So since you know that 1 and 3 are equal, you can subtract them away. And you're left with the measure of angle 2 equals the measure of angle 4, which is subtraction. And technically we have congruence. Now, for our purposes, congruence and equal are interchangeable. But if it really makes you upset, you can say this. And you would just say, if the measures of 2 angles are congruent, then they are equal. All right, let's do our next proof. Given that ST is equal to NR and TU is equal to LN, I want to prove that the big pieces are the same. And here we go. So I'll start with my givens. ST equals NR and TU equals LN. And that's all I know. So to say something else, I will use my segment addition postulate this time. Now I've gotten everything I could from the picture. Now I really just have to focus on making SU and LR be equal to the same thing. There are a lot of different options that you can do. I'm going to look at my givens, and I'm going to try to combine those givens together. Remember that the addition property says that you can add parts that are equal. So I'm going to say that ST plus TU, combining these two parts together, equals NR plus LN. combining the other two parts together, which is just the addition property. And now, notice you have ST and TU and ST and TU. So I can replace SU here. And I have NR and LN and NR and LN. So I can replace LR in here. And I am finished. Now there are other things you could have done for this proof. You could have just substituted NR in for SD and LN in for TU and substitute it again. There are several different options for this particular proof. Let me check yours if you think you're right and you're different than me. Now let's look here. I know that ABC is bisected and the measure of angle 1 equals the measure of angle 3. So if ABC is bisected, that means that angle 1 and angle 2 also have to be the same. My goal is to say that 2 equals 3, so I'm almost there. Let's write down our givens. You always have to write down your givens exactly how they are written. So yes, we know that ABC is bisected, and that's great, but we have to actually use the fact that ABC is bisected and take an extra step, which seems kind of silly sometimes, but to say the measure of angle 1 equals the measure of angle 2. And your reasoning there would be, if a segment is bisected, then it is divided into 2 equal parts. And now, conveniently, all you have to really do is focus on your substitution. So angle 1 equals angle 3, and angle 2 equals angle 3. So you can do a little substitution here and say that. Okay, here's proof number 5. So I know that A, B, and D, E are congruent, and I know B, C, and E, F are congruent. I know that A or B is the midpoint of AC, meaning that AC is divided into 2 congruent parts. And I want to prove that E is the midpoint of DF. So if this is a midpoint, that means that AB and BC are also the same, which kind of means in turn that everything is going to eventually end up being the same in this picture. So let's start writing again. AB equals DE and BC equals EF. And then B is a midpoint of AC. All of those are given. Let's use this midpoint definition. AB is equal to BC. And if we have a midpoint, then 2 can equal or congruent segments. Now, if we're going to say that E is a midpoint, and that's our end goal, I need to say that DE is equal to EF. So that's really what I need to work my way towards right now. So if I know that AB is equal to DE, then I can again use my favorite property and substitute. And if I know that EF is equal to BC, I can also substitute. So I can say DE equals EF, again by substitution. Now that I've said that DE is equal to EF, I can say that D is a midpoint, or E is a midpoint. Because we have two congruent segments. So if the segment is divided into two equal segments, then you have a midpoint. And now number 6. Number 6 is probably the most challenging on the assignment today. So I know that LMN is bisected. I know that ABC is bisected. And I know that 1 equals 4. I want to prove that these two big angles are in fact congruent. This is really combining a lot of the different rules that we've already talked about. In this particular proof, there are a lot of ways to do it. So I would say let's use the bisecting part. So I know that angle 1 equals angle 2. And I also know that angle 3 equals angle 4. So I would call those givens. And that would be if bisect, then 2 equal parts. Okay, so now comes the interesting part. To prove something about angle LMN, I have to say something about LMN. I know it's bisected, but I need to do more. So let's focus on, again, that angle addition postulate. The measure of angle 1 plus the measure of angle 2 equals the measure of angle LMN. And then the measure of angle 3 plus the measure of angle 4 equals the measure of angle ABC. And that's your angle addition postulate. Now, I know that these two pieces are the same, basically because of these 3 statements. So I really just need to work on maybe doing some substituting, okay? You can substitute in a lot of different ways. But the ideal situation would be that LMN and ABC equal the exact same thing. So if I know that 1 and 4 are the same, like I can plug in 4 for 1. And I know that 3 and 4 are the same, so maybe I plug in 4 for 3. Now I'm almost exactly the same. I really need to make this 2 be a 4. I don't directly have a statement right now that says that 2 is equal to 4. So I kind of need to say that. So I'm going to backtrack a little bit in my proof. Maybe I'll squeeze that statement in right here. And I will say that angle 2 equals angle 4. So that way, Now I can say the measure of angle 4 plus the measure of angle